If a cometary nucleus comes within 4 astronomical units of the sun, the sublimation of Ices produces a coma that may be as much as 10 to the 5 kilometers in diameter. In addition, the sublimation releases chunks of rock and dust particles that were previously locked inside the ice. So, depending on what's inside, the sublimation will release those types of things from a comet. The gravitational force of the nucleus on the gas and dust of the comet is small. Thus, material from the comet is easily driven away by non-gravitational forces. Ionized gas is swept away by the charged particles in the solar wind and forms a long, narrow ion tail. So if your gravitational force is not, huge, you're going to be influenced by other things, such as, for example, a solar wind can kind of blow part of you away, basically. Tiny dust particles are pushed away from the coma by the gentler force of radiation pressure from sunlight. So another thing that may happen is radiation pressure from sunlight. Tiny dust particles are pushed away from the coma by the gentler force of radiation pressure from sunlight. The dust grains form a broad, curved dust tail. Thus, comets generally have two tails. Although from some viewing angles they are superimposed and appear as a single tail, in extreme cases a comet's tails can be nearly 1 astronomical units in length. So very long-tailed things. Comets can be divided into 2 classes based on their orbital parameters. Short period comets are those with a period of less than 200 years and hence a semi-major axis of less than 34 astronomical units. Short period comets have other characteristics in common. Most short period comets have moderate inclination. I is less than 30 degrees, though a few are retrograde. I is greater than 90 degrees. Most short period comets have fairly large eccentricity with an E of around 0.8 is a typical value. At present, there are roughly 200 short period comets known. The most famous short period comet is Comet Halley, Halley's Comet, with a P of 76 years, so pretty short compared to the periods. It is also one of the few retrograde short period comets with an I of 162 degrees. After a few hundred perihelion passes, a comet tends to lose all its ices. So after, going around the sun and coming close to it, enough times, it's sort of lost its ices because of sublimation. Thus, after less than 10 to the 5 years, so less than a million years, a short period comet becomes an inert pile of rubble. An inert pile of rubble. Given this brief time scale, there must exist a repository of cometary nuclei in the cold outer solar system from which the supply of short period comets is replenished. One obvious repository is the Kuiper belt. This would explain why most of them have relatively small inclinations, which match the relatively small inclination of the majority of Kuiper belt objects. But how can we explain the short period comets that are on retrograde orbits? To explain the origin of retrograde short period comets, it helps to consider the origin of long period comets. Long period comets are defined as comets with period of more than 200 years and hence semi-major axis of more than 34 astronomical units. Some long period comets have periods that are very long indeed, with a period of around 3 times 10 to the 7 years, implying a semi-major axis of 100,000 astronomical units. Long period comets have other characteristics in common besides their long orbital periods. These are as follows. Long period comets have random inclinations to the ecliptic, with as many being on retrograde orbits as on prograde orbits. Long period comets have extremely high orbital eccentricities of around 1. Over 800 long period comets